Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Rosenwald here. We're going to be working on the chapter 2223 notes. Pretty much 2223 and 24 kind of combined into one little note sheet. This is one that was actually posted on Schoology and we went through in class, but these are the videos. This is the video that's going to kind of guide us through it again in case you needed it. More importantly, what I'm going to be doing is on this video, I'm going to show you guys how to use Desmos a little more efficiently to get you through these problems a little bit quicker. So with that said, let's go ahead and get started here, okay? Let's move me out of the way as usual. All right, so let's get started. So in this unit, we have a lot of definitions, a lot of new terms that we're actually working on. You know, the first one being we're talking about the standard form of an equation, of a quadratic, and that's that form ax squared plus bx plus c, because quadratics have that square in it. The standard vertex form is the same equation, but it's kind of rewritten and modified so that we have y is equal to a times x minus h squared plus k. We call this one the standard vertex form because when we look at this problem, you have this h and this k that's embedded inside of this. That leads to our vertex. Now, our vertex is when we're looking at a curve, it's a point that's on my curve where things change direction. So if we were to go ahead and look at a curve, let's pretend like this is our graph and this is a curve. The point where my graph changes directions, sorry, I just lost that by touching it on accident. The point where my graph changes directions, you can see what's happening is the graph's going down here and then the graph goes back up here. The point that's in the middle right there, we would call our vertex, okay? And if I was to go the other direction, let's say the graph was going up and then down, you can see the graph is going up in this direction, then it's going down in this direction, so the change happens right here at that spot. We have names for those, which we'll get to in a moment here, but the point itself is called a vertex. That's the top or the bottom point. The axis of symmetry is the line where we have symmetry on both sides. It goes directly through our vertex. You'll get the hang of that as we kind of work through it. The maximum is a point that's at the top of the curve. So again, if we were to draw this and I say the max is at this point right here. It's the vertex, it's just that it's called a max because it's at the top. And if I was to draw a curve and make it go this direction, we would say that this point down here is a minimum because it's the bottom point in the graph. It's the vertex, but it's still a bottom point. And then lastly, we have a definition talking about zeros. And so when I look at a graph, zeros are where my graph actually hits the x-axis. So these 2 points right here would be considered zeros in this picture here, okay? And then I can do it the other direction. If the graph was going like this, we would say that these 2 points right here are called zeros. We'll talk more about those a little bit later, but let's jump into some actual problems here and get the gist of how to actually work through these, okay? So when we look at this right here, this is currently in that standard vertex form, where we have it's equal to a times x minus h squared plus k. All right, and so when we look at this, that's that standard vertex form, we're going to pull the vertex directly out of the information that's given to us. So this right here is going to get pulled out and is going to be my h, and this right here will get pulled out and this is going to be my k. Now, one thing to remember is that whenever we're looking at this, this value is always directly given. If it's a positive 4, it's going to stay a positive 4. But this value right here, you notice how it says minus here? It says to take the opposite of the h value. And so since I have a positive 3 here, the opposite of a positive 3 means that we're going to have a vertex at negative 3. So this is my vertex. Okay. For my axis of symmetry, this line is a line that has to go directly through my vertex. And because it goes directly through my vertex, it's going to be a vertical line. I'll show you in a second what that looks like. And what we know is that for the axis of symmetry, it's always x equals, okay? Well, if we look at my vertex here, this is my x value. And since my x value here is negative 3, that means my vertical line is x equals negative 3 is my axis of symmetry. So let's put this all together and look at what this graph actually looks like. We have a vertex at negative 3, positive 4, okay? We have an axis of symmetry at x is equal to negative 3. So let's go ahead and make that vertical line right here through negative 3. And you can see that it's this vertical line that goes directly down the middle of this point. It's a vertical line that goes straight through it, okay? And then we're going to draw the points that go along with this. Now, normally, if we remember, our points for these, I'm going to draw a point that I can use here. Normally, when we have a point, it goes one away. It usually goes one up. And so we have one up and one up over here. So usually it's in these two spots. Well, If we look at what's going on here, this -2 that's right here, that -2 says that it's going to reflect over, and then it's going to be stretched by 2. So instead of it being up 1 over 1, it's going to be down 1 over 1. It's going to be reflected, and then we're going to stretch it by 2. So instead of it being 1 away in this direction, we're going to make it go 2 away. Okay? And then we'll do the same thing on the other side. So I've got another point here. Sorry, give me one sec. I've got another point right here. And that point, we're going to go ahead and do the same thing. So it's going to normally be 1 up from here. If I stretch it, it's 2 up. But then I reflect it over, it goes back the other direction. It's going to be down here. Okay? That one did not get moved to where it belonged. And that's it. So we really just need 3 points to make our curve, but this is what our curve looks like. So let's talk about a couple of keywords and definitions here, okay? Just kind of keep reiterating it. This point right here is a vertex, okay? This line right here is an axis of symmetry. This point right here is, since it's at the top of the curve, is called a max, okay? These points right here where it hits the x-axis are called zeros. There you go. That's everything in a nutshell here, okay? So let's jump into a couple more problems here. All right, this is in that standard vertex form, so let's look at this. So we have a times x minus h squared plus k. All right, so let's go ahead and pull our vertex from here. We know that this is going to be exactly the same, and we know that this is going to be the opposite. So using the exact same value here, we're going to have a -2 get pulled directly out of there. That's the wrong thing. I'm going to pull a -2 directly out of there for my vertex. And then again, this right here, that negative that's right there, says the opposite of h. And since h is a +4, we're going to go ahead and do a -4. So this is my vertex. Okay. And from here, my axis symmetry is exactly the same. So my axis symmetry is going to be x is equal to -4. That's my AOS. All right, let's go ahead and put our points in here. So we have -4 and -2. Okay. Our axis of symmetry is going to be a vertical line that's going to go directly through this. Okay, so we have x is equal to -4 is my axis of symmetry. We have my vertex right here, which is at -4, -2. Okay. From here, let's go ahead and plot our point. So again, looking at this, we know that we have a vertical shrink by 1/2. And so that means, and it's not reflected, so that means that normally I have a point right here at this spot, 1 up and 1 over, and I have a point at this spot, 1 up and 1 over. And so what's going to happen is we're going to take those points and we're going to go halfway down from where they're normally at. So it's normally right here, and we're going to go halfway down, and it's going to be right here. And normally this is right here. We're going to go halfway down, and it's going to be right there. Another point that we can use, remember, is traditionally we have a point that's 2 away and then 4 up from there. So normally there's this point right here, and there's another point right here because of that axis of symmetry. Remember, that symmetry says it's the same thing on both sides. And so what ends up happening is we're going to take those points that are there, and we're going to go half the distance. So normally it's 4 away. Half of it is now going to be 2 away. And normally it's 4 away in this upper direction. Now we're going to be 2 away instead. And so this is what our graph ends up looking like. Okay. And when we look at this, we can see we've got our zeros. And there's a 0 here. Okay. This point right here, which is my vertex, is a minimum because it's the bottom part of my shape. So that's all parts labeled in this, okay? All right, let's jump into some more problems here. What happens when I don't have this really nice equation where I've got the standard vertex form? If our goal is to get this y is equal to a times x minus h squared plus k, that's that standard vertex form, I can use the information that's given to us in this problem here. This right here, that x squared minus 6x plus 1, we can pull information from that by using some formulas that we know. First thing we know that the vertex has a formula. It's negative b divided by 2a. So this is currently in that standard form, plus bx plus c. And if I pull the information that's given me, this right here is my a value, this right here is my b value, and this right here is my c value. we can use those values to go ahead and create our axis of symmetry. We know that x is equal to negative b divided by 2a. That's the formula that's given to us for the axis of symmetry. So that negative b is another way of saying this is we could say right here, that says the opposite of b. So if my b value is a positive value, I would take a negative. If my b value is a negative, I would take a positive. We're just using the opposite value. Well, since my b value is a negative 6, the opposite of negative 6 is a positive 6. Okay? We have 2 times my a value. My a value in this is equal to 3. So that means we have 6 divided by 6, so that equals 1. So my axis of symmetry is x is equal to 1. Let's go over here and produce that vertical line at x is equal to 1. Next, since we know that my vertex has a value of 1, that my axis of symmetry has a value of 1, remember we said up here that your axis of symmetry and the x value in your vertex are going to be exactly the same. And since your axis of symmetry and your vertex are going to be exactly the same, that x value, let's use that to our advantage. Since we know that this x right here is the same as this x up here, and it's the same as this x right here, we can plug it in for those x's, and I could find the y value from there to give me my vertex. So let's do that. If I take that 1 and I plug it into my equation, let's take this 1 and plug it in for the x's. Okay, and again, that equation just came straight from up here. I'm just replacing my x's with a 1. Okay. We end up with 3 times 1 minus 6 plus 1. So that's 3 minus 6 plus 1, which is negative 3 plus 1, so negative 2. So my vertex, if I put these together, is going to be 1, negative 2. Here's my vertex. All right. So knowing that my vertex is at 1, negative 2, let's go ahead and put a point right here at 1, negative 2. Okay. And then we should be able to go ahead and do our graph from here. Well, how do we get this graph from here? Well, let's look at what we know. Get it back in that standard vertex form. The a value in this is a 3. So that's the a value right here. It's a 3. So let's put that 3 in there. My vertex that's given to me, let's just pull these points back into here, is going to go here and here. Okay, so we're going to put in the values here and here, just like we normally would. Instead of pulling it out, we're putting it in. And we're going to have an x minus a 1. We're going to use the opposite of this, like we always do. So the opposite of this gives me that minus 1. And we're going to keep this same value here of that negative 2. So that's going to make this a minus 2. Okay, so there's my standard vertex form based off of the equation we just had. So now let's go ahead and do the graph. We know the graph is going to be stretched by 3, so let's go ahead and stretch it by 3 in each direction there. And there's no reflections here. So if I go ahead and I normally have this value 1 away, so it's normally 1 up from here, 3 times 1 now makes it 3. So instead of being 1, I'm going to be at 1, 2, 3 away. And we're going to go ahead and duplicate this so it's over on the other side, same distance. Okay. And then my other point is normally 2 away. Let me go ahead and make that. So my other point is usually 2 away and 4 up. Well, 4 times 3 makes this 12 up. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12. And I will duplicate that and put that on the other side. And there is your curve. And this graph, when we look at it, that vertex is a minimum because it's at the bottom. And you can see the zeros are right here, but they're not very nice. But nevertheless, those would be the zeros. Okay? All right, let's do another one here. We're going to go a little bit quicker on this now. Again, pause it if you ever need it. All right. My a value, my b value, my c value. Okay, so we have x equals negative b divided by 2a. So the opposite of that b value, which is a negative 4, is a positive 4. My a value is equal to 1/2. That's 0.5. So we have 4 divided by half of 2, which is 1, which means we have 4. So x equals 4 is my axis of symmetry. So we'll go ahead and put that in there. There's my axis of symmetry. And let's continue on. Knowing that 4 is my x value, we're going to take that and plug it in for the x's here and for here. So let's rewrite the equation. We have 0.5, 4 squared minus 4 times 4 minus 2. So we have half of 16 minus 16 minus 2. So we have 8 minus 16 minus 2. So that means we have negative 8 minus 2, or negative 10. So my vertex for this is going to be 4, negative 10. Okay, so let's go over to 4, negative 10 to make a point. And then let's go ahead and create this standard vertex form, just so we're practicing this. A value in this is equal to a half, so I'm going to use that half that's right there and put it in for my A value right here. So we're going to have 1/2. Using my vertex, we're going to go x, and we're going to use the opposite of that 4. Okay, that's going to go there. So we're going to have minus 4. And then that minus 10 will come straight up, and there's your standard vertex form. If I wanted to go ahead and graph this now, instead of going 1 away in each direction, instead of going 1 up, we're going to only go halfway up. So we'll go halfway, duplicate that, and we'll go half the other direction. I don't know what's going on here. My pen is acting very wonky these days. It's a little annoying, quite frankly. All right, let's go ahead and move that over there, and it's at half. And then to do one more point, normally we're 2 away and 4 up from the point. And so we're going to go half of that and bring it down to 2. We're going to duplicate that, and we're going to go half away. Oops, hang on. And we're going to go to 2. Okay, and this is what our graph is going to look like. All right, let's continue on. So we're done with 4 problems. Got a few more to go here. All right, and these are going to get a little quicker as we work through them. Okay, so working on number 5 here. Again, this is just determining the maximum or the minimum. We're going to go ahead and skip the whole domain and range portion of this. We're just doing the maximum minimum, which is also known as the vertex. Okay, so we get x equals, it's going to be negative b divided by 2a. So we get, I'm done with that. My pen is not working. I'm getting very annoyed. Okay. So now my handwriting is going to get a little sloppy. I'll do the best I can to try to make this work out. Okay. So we have negative b divided by 2a. So we get the opposite of my b value. This is my a. This is my b. So the opposite of b is going to be positive 2. My a value is 1/2. So we're going to have 2 times half, which is 1. So it's just going to be 2. So we get x equals 2 is going to be my axis of symmetry. We'll put that into my function. So now we get 1/2, a 2, a squared minus 2 times 2 minus 1. So we end up with half of 4 minus 1, which means we have 2 minus 4 minus 1. So we have negative 3. So my vertex is going to be 2, negative 3. Okay. And since my graph, when we look at this, that value right there, that 1/2 that we have right here is a positive, that means my graph is going to open like this. And so therefore, since my graph opens upwards, this vertex is going to be at the bottom of my curve, which makes this a minimum. Okay. All right, let's keep going. Again, we have my a value is going to be equal to 2. My b value is going to be equal to positive 8. So we have x equals negative b over 2a. So we have x is equal to negative 8 divided by 2. So we have negative 4. Hang on, just made a mistake. Just disregard, I ignored the 2 that was there from my a value. And so we have negative 8 over 4, which means we have a negative 2. So we get x equals negative 2 is my axis of symmetry. My vertex then is going to be 2 times negative 2 squared plus 8 times negative 2 minus 6. So that means we have 2 times 4 minus 16 minus 6, which means we have 8 minus 16 minus 6. So we have negative 8 minus 6, which is negative 14. So we have a vertex at negative 2, negative 14. Okay? And then when we look at this, we're going to go ahead and say that this is a minimum as well, because that a value is positive here. That means we're going to have a curve that's going to look like this, which makes it a minimum. Okay, so this is a min. So I said to you, there's a way to actually use Desmos to be really efficient with this stuff, and I'm going to show you right now how to do that. We have 2x squared plus 8x minus 6. Watch what happens when I put this in. We are going to have y equals 2x squared plus 8x minus 6. And if you look, here's your curve. Okay, this is what our curve looks like. And if I said, let's find the vertex for this, watch what happens. I can just touch the screen. Watch, I'm going to take my finger, I'm going to touch right here at the bottom of my curve. And you can see by touching the bottom of my curve, it gives me that coordinate, that vertex of -2, -14. All right? And by doing that, we know automatically then the axis of symmetry would be x equals that value of -2. And you can see that that line goes directly through the middle of my curve. Okay? All right, let's carry on here. So now we're going to try to find the equations from graphing these, and we're going to be looking at the x-intercepts, the vertex, and the axis of symmetry. This is super easy to do when you have it in this form. How do we find the zeros? Well, the way that we find zeros is if you learned back in algebra, there's this thing called the zero product rule. And what it says is that if I have two binomials equal to 0, the only way that this works is if by chance one of them happens to be equal to 0 or both of them is equal to 0. So for example, if I put a big 0 right here, okay, well 0 right here times this entire thing, 0 times anything is just 0, right? The same is true if I said, well, what if this was 0? 0 times all of this here would be equal to 0. So the question then is, well, what would have to happen for this to be equal to 0? Meaning, what would have to happen to x plus 3 for it to be equal to 0? Well, x would have to equal -3. That means that we have a 0 at -3, 0. Okay? If I do x minus 1 is equal to 0 and solve, we get x is equal to 1. That means that we have at 1, 0. So these are now zeros that are on my picture. We're going to use these, and this is going to help us immensely. If I go to -3, 0, make a point, there's a point right here at -3, 0. I'm going to do that a little bit better, sorry. At -3, 0, there's this point, okay? And then the other point we said is going to be over at +1, 0. So these are now zeros that are part of my picture. Now here's the deal. The axis of symmetry is a line that has to sit directly between these 2 points. And if we look at this picture, you can hopefully see that there's this line that goes directly down the middle of this picture, okay? Not a very straight line, but nevertheless, it's a line. And you can see it goes through the middle. Well, what's the x value that it goes through? The x value that's right there. That x value is a -1. This right here is my axis of symmetry. So if I say to you, all right, well, great, we know the axis of symmetry, how do we find the vertex? It goes back to exactly what we did before. You're going to take that axis of symmetry and you're going to put it in for each of the x's that are in my problem. Okay? And then we're just going to simplify it. So we end up with a -2, this is a +2, and then a -2. So that means this ends up equaling 8. So my vertex is going to take my axis of symmetry, which is at -1, and my 8 that we just found, and my vertex is going to be at -1, +8, 4, 8. So there we go, right there. And now we have all the information we need. I've got a couple of zeros here. I've got my vertex. I now have a picture. Okay? And that point at the top, that is a max. All right, let's try this one more time. We're going to go a little quicker. All right, if we solve for x here, we get that x is equal to 4. So we get a vertex, a 0 at 4, 0. If I solve for x here, we get that x is equal to -2. So now we have a value at -2, 0. Let's make points at 4, 0 and -2, 0. Okay, we're going to go ahead and make my axis of symmetry right down the middle of this. We can see that that line is when x is equal to 1. Okay. Now that we know what the axis of symmetry is, let's go ahead and throw that x value into my equation. So we have -1/3 times 1 minus 4 times 1 plus 2. And we have -1/3, that's a 3, excuse me, times -3 times 3. And so when we multiply this out, we get -9 times -1/3, which is equal to +3. And so that means that we have a vertex at 1, 3. That's just using my axis of symmetry from the problem here that we just found, and then using my y value that we just found and putting those together, and we have a vertex at 1, 3. And then we can go ahead and graph it, and there's our curve. All right, last 2 questions. These are word problems here. The word problems are basically just, can you make sense of what's going on and look into the zeros, okay? So let's look at the pictures for these. This first picture, this equation right here, all I did was I used quadratic regression, and I put in these 3 points. And by using quadratic regression and putting these 3 points, I went ahead and found this equation. So let's look at Desmos here. Okay, this is what that first equation looks like. All right, I'm going to go ahead and zoom out so I can see a little bit better here. All right, and what we could see is that my graph starts at 0. This is where the guy's standing at. The ball gets as high, it gets as high as 25 feet. You can see that right here it goes up to 25. We got that along here. That's the highest it gets to. And then it gets all the way out to 100 feet in front of him. So the question asks, let's compare each of his hits. Right? When we look at this, it says, based off of this, the path of his second shot, so if we follow along with what's going on here, his second shot is this equation right here. And it says which shot travels farther before it hits the ground and which one travels higher. Well, let's take a look here. Here's the second equation. So you can see by the second equation, what happens is it still starts at 0, 0, just like the other one. It goes all the way up to 40, 32, and then it ends over at 80. So the second shot, this blue one, you can see it goes higher than the purple one, but it doesn't go as far as the purple one. So to answer the question, which one goes higher and which one goes further, this equation goes further. Okay, that was the original equation. It goes all the way out to 100, but this one goes higher. Okay, let's take a look at the last question here, which now uses the same idea, but now it's using this equation. It says which one travels higher and which one travels further. So let's look at this one and see what happens. Okay, this is my last one, and you can see it's not a very good hit. And what happens is it starts at 0 here, it goes all the way up to 12, and then back down to 40, 0. Versus when we look at, I'm going to zoom out here so we can see everything. Okay, let's pull all these points up here. You can see that this one only gets 12 high versus this one gets 25 high. The purple one gets 100 far versus the green one, which gets only to 40. So which one gets higher and which one gets further? The purple one gets higher and it gets further. Okay, so we can say the original, that one, gets higher and further. There you go. So I know that I went a little quickly through some of these problems, but the beauty of the video means that you can pause it, rewind it, go back and check anything that you have questions on. But I'm confident you guys can get through this. I know it's a lot, but it's just repetitious stuff here, okay? You guys take care, be safe, be respectful, be responsible, excuse me. Let me know if you have any questions. Until the next time, you guys be safe, and we'll talk to you soon.